Well, welcome to part 2 of our session that was on intervention, and a lot of good questions from last week, which we'll deal with during this session. But I'm here with Narelle, and actually Narelle's going to run a large chunk of this section, and we'll talk about that as we head through. But just a few reminders before we start. There's some material that you may want to have in place, particularly if you've got some blank paper and some counters. That will help a lot. There's a number of different documents we referred to, and we've given the references for those. And if you wanted to download them or have them available at some point, that'll be handy, particularly if you're watching again later and so forth. So essentially, we've got a lot to get through, and we're going to try and do it in a little bit quicker than last week. So let's head on the track. A couple of reminders from last week, one of which is we're really talking about these tiers, or sometimes referred to as waves of intervention. Last week we spent a lot on the green section. Roughly 80% of our kids be there, and that we're talking there, even within that percentage of children, you still need a differentiated curriculum. So even there, not everyone's going to pick up everything directly. This week we're going to focus more on the next 2 tiers, tier 2. We'll talk about percentages later there, but that's where children might need some shorter term intervention. You notice some issues that are going on, quite focused. Yeah, it could be groups of kids. The next level is the pointy end, literally, where you need a lot of support and intervention and so on. So basically, we'll look a little bit at some of the definitions and explanations, and some of the words may be a bit unfamiliar, so we'll describe what they are. Some of the characteristics, and I'm going to particularly use Narelle's experience there, because she's had a lot of experience, and you'll see as it unfolds. And then we're going to focus on 3 general ideas that cause some issues. You've got counting, addition, subtraction, and hopefully we'll get to word problems in that sense there. So that's the journey we're going on. Now you might notice there's a little triangle there. It's a reminder both to Narelle and myself to talk about this notion of this concrete representational abstract idea that happens in mathematics. And both of us believe there's a bit of a missing link. And as we talk about that, you'll get the idea as we go ahead. So hopefully everyone's settled in and ready to go. And once again, a little bit of the theory, but we're going to try and give you some practical support and ideas. And we put together a few different sheets that might be of help. Obviously, we could probably put the disclaimer. This is general advice in that we're not working with the individual children. But I think there's going to be some good general advice there that happens. So just a comment from last week, and I'll just take our faces off so everyone can see this without us, so to speak there. Last week there were some questions that came up about trying to support children, and Narelle made comment about this website, so we just wanted to make it aware.
So
can you tell us about it?
What I like about the NCCD website is these podcasts, and you can bring us back now so they can see us talking. What I like about them is they're really good for making adjustments at wave 1 to help the students that have difficulties or disabilities. So instead of just doing something for one small group of students, you make a whole class change that benefits everyone. So I feel like teachers have so much to do and so much put on them, whereas these videos are quite nice in helping them make that change at the green zone, which then filters to the others.
Good practical advice, and as you've used them, that makes sense to do that. So that's good, and I like the idea of just not having to make a specific change for one child. The whole class
There's
can
enough
benefit.
to do.
Yeah, that's good. Okay, so that's just a little follow-up from last week. Now, essentially, we talked a lot in the green zone last week. We're talking now, toward the pointy end, 15 to 20% of students. Now, different schools, different places will be, last couple of weeks I've worked in what we call Ed Support Centres in WA. So they would obviously have, most of their students would be here. And then you've got what we're going to call the pointy end. And there's words used in that end like Dyscalculia and so forth.
Or if you're English, Dyscalculia.
Okay, that's fine. Well, whatever it might be, depends on which side of the river you might be on. But they're mentioned in your guide. So remember last week, if you've got the guide there, that'd be really neat. Okay, remember we referred to this guide. That has a lot of those definitions. So we're not going to spend a lot of time on that. But there's an explanation of what that means. So people can read that and download that as well. So that's one of those things. So we're going to just follow that through. So that's where we'll be playing today in particular. Now, a little comment here. These are some of the definitions that come from that document. And you see that we've already referred to some of that. But words like dyslexia come up and so forth. And often you'll find some of these children have like a double whammy. They've got this and this, going on. And sometimes you'll need to have a look at one element first and try and work out, so there's some dyslexic things going on here that are impacting on the mathematics and so forth. That's all we wanted to say. We're not going to get deeply into that.
Yeah, and just that the disability is a subset of difficulty.
Yep.
I think is the thing to bring out from there. And very much that with the learning difficulties, that bit about they cannot improve with they need more than high quality instruction alone. So this is in addition to your wave 1.
Okay, so so actually you're making that distinction, and you've worked in this field in a school environment, and you're right. So you need extra support at this point.
The words in that document from Victorian Government is in addition to.
Yep.
So,
Okay, so that clarifies that for us in that sense. So let's go on our journey now, and hopefully everyone's there now. I quite like this. It's just a little quote once again, page 10 you'll find it on. We're not going to read it to you because everyone can read, but I like the little phrase, there's no one size fits all. Now, I have to comment here, we're not exporting, this is Josh.
This is mine.
Yeah, so just a little bit of background so people appreciate one of the reasons why you have a real interest in this area. That's Narelle's son, Josh. You want to tell us a little bit about Josh?
Yeah, so Josh was diagnosed with autism and ADHD when he was 3 and he's now 10.
Okay. And essentially, so you've worked with me in a clinic that we ran for children who had struggles. You've worked in a school environment, both at the top end and the struggler end.
Yeah.
And in sense of trying to help and withdraw at times.
That's right.
And now you're homeschooling.
Yes, I think the Victorians I have a little bit more empathy with you now.
So you can give us 2 points of view. The one of, as the teacher trying to do this, but as the parent.
Being on the other end of it,
Okay, so that's why Narelle's particularly going to have quite a role today in that sort of thing there.
And my reason for using the little picture of Josh was not to exploit him, but when I look at children, one thing I really try to keep in mind with intervention is when you look at a face, we all have 2 eyes and 2 ears and we only have 1 mouth. So we need to speak a lot less than we listen and observe the child. And then when we work out what they're doing and why, that will then inform how we intervene. So that's why there is no one approach. There are evidence-based is the big word, and research-informed things that can guide what we do, but there is no one magic bullet.
Okay, so that sounds good, and it's coming. I can hear the heart there because you've got a vested interest.
I 20 years of working with students at both ends, you see that they are all different. Yeah, there are some similarities. But...
Okay, so now here's one word that I wanted to bring up a little bit. When you read all of this stuff, and it's confusing if it's not your. So we've highlighted this idea of numerosities. Now, I just need to get a little background here. The person we're quoting with is Professor Brian Butterworth, who's the expert in this field. He's been to Australia several times, obviously not recently, but he has a website called The Mathematical Brain, and fascinating sorts of information. But I worry sometimes you read this information, if I was a parent or something, what's a numerosity? So, Narelle, are you happy to explain what a numerosity is?
That'd be great. And at the beginning of the slide, I said we were first going to do the theory and the characteristics because you need to understand that to inform how you intervene. So the point of looking at these characteristics of dyscalculia or the learning difficulties is to be able to inform what we do with the intervention. And if we just go down to the visualizer, I'm just going to put a whiteboard here. So this word numerosity, what it actually means is that when you hear the word 3 or you see the number 3, you attach to this an understanding of how many this is. Now, that seems like a small thing, but people with dyscalculia don't typically understand the quantity in relation to that word. So the word 3 or numeral 3 is not significantly different to, say, 8. Whereas when you and I think about 3 and 8, 3, I think this, I think 3 dots, I think triangles, I think 1 more than 2, and I think 1 less than 4, and I think 8, well, that's nearly double, and I have all these connections that contribute to the how many or the numerosity of it.
Okay, so if we want to simplify this down, we're looking for more connections, and obviously for some of these children, certain connections are harder to make than others.
Very much so. Yeah, and this idea of making those connections is what we're going to bring out through this whole presentation.
Brilliant.
So we can go to the next slide.
Okay.
Oh, sorry, just before we do that slide, this is, okay, so the triangle.
Yeah, which we referred to earlier.
Yes, so can you see here, we are wanting to connect the physical material to the oral language of 8, not the spelling, and the written numeral or number 8. And so it's making these connections, and the numerosity bit is just putting that quantity with the number. But as we go through, I want you to keep an eye on me making these connections.
Triangles.
Yes.
And I see that the way you've laid those counters out, we're seeing there's a length clue that's going on there.
And there's a length related to 5. You'll notice the 2 colours, very important with the hands. Yeah. So just on 8, children tend to gravitate towards doubles. So most children don't have a difficulty with 8 as 4 and 4. After 5 and 5 we get a bit tricky. We don't do 6 and 6. But 8 as a 5 and a number, that's another whole kettle of fish, which is what we want to target our intervention to.
Okay, so it's quite subtle. So at times, I might ask you to, so what did you mean there? Just to pull that up. So, and look, basically part of this is experience, seeing this happen on a regular basis. So now can I move to the next slide? Okay, thank you. All right, so there we go. So I've had one job here now is to move the slides, and I'm not even
stuck.
There we go.
Yes.
Yep.
So looking at that triangle, language becomes very important. And with the numerosities, it's all about this idea of what is bigger and what is smaller. Those 2 words in themselves are quite tricky. The reason they can be tricky, if we can just flick to that slide down here, is a person with dyscalculia may see this is physically bigger. But what we need to understand is which is mathematically bigger in value. So if we go back to the PowerPoint, there is some language, and of course we always start with what children come and bring with. So they will bigger, older, smaller, those words, and we start with that. But as teachers, if we have a clear understanding of the language, we can then move them on to the next thing.
Okay, so we basically, good teaching, start from what you know. And to find that out, we've got to listen.
Yes.
Okay. But the second is, in our head, we have to have a progression in mind.
That's right.
Now, many kids, even mainstream children, will get some of these issues themselves. It'll come up. It's just being able that you're forewarned, you're forearmed. You can spot it, so then you can do something with it.
Yes, that's right. And you're right, with the mainstream students, things like, that it can be a larger physical thing, but worth less or way less. Ooh. So these words become important. This is a free download for you. I'll give you. We just go back to the visualizer for a second.
Okay.
You've had 2 downloads that we emailed to you. One was this one that we're going to use in a minute, and the other was this one. And this has got all the links with all of the downloads for you.
Okay, so things we mentioned throughout.
So don't worry about trying to sketch it all down.
Okay. So ready to move on? Brilliant. Okay, so let's head along here. So tell us how you use the desk visual.
All right, so just to give an overview of where we've come from, we've looked a little bit at the theory, we've looked at the definitions, and that people with dyscalculia need to link this sense of size of the value of the number. So we're going to go into some counting activities to show how we could do this using a progression from concrete to representational to abstract.
So this is that CRA, that we talked about, that triangle again.
That's right. And we're going to go through a few activities. At home, you're going to do some in a minute at the concrete end, and then we're going to do some at the representational and abstract end for counting. Just before we get into it, if you can humour me, and Paul, you can play along.
Okay.
Looking at that desk visual, before we do it, we've got to preload the language and the skills. Now, just a disclaimer, if you're working with students that have OT difficulties, don't make them make 3 like this, but as long as they have 1 representation that they can consistently see without counting.
Go on, just show us that, what you just did there.
So I'm doing 3 like this, but
I can see,
lots of students actually have difficulty with the separate. It's an OT issue. Anyway, some of them will have to do 3 like this.
Okay.
I'm not being legalistic about which one. but I am being very specific about not counting.
Okay, so there's your differentiation that's happening within that. Yeah. Okay. Yep.
So let's just practice, go to the PowerPoint so we can all make, let's all make, and you do it with me, one. Yay!
Okay,
And can you see we're matching the word with the quantity at the same time?
So we're trying to get,
All right, I'll do, then you can do 2.
Okay, so I'm going to 2.
Excellent. 3.
3.
4.
4.
5.
5.
Now, as we go, we'd obviously do that in lots of practice sessions, etc. But the idea is, so students with dyscalculia will need to feel the need to count even very small objects that we could subtitle up to 3. So we really want to get them trusting the feel of that.
So what we're looking for there is we don't want them going
3.
Okay, so that's what we're spotting. Okay,
Yeah, so that's why this desk visual, if we actually put it in front of them, they can match it. So not all students will need this, but some will.
So this is like the support or the scaffold.
That's exactly right. And we would rather them have this and access this than continually count by 1 every time they make 3.
And look, it's a bit subtle, but as I can see as the counters, they're going further, longer.
Yeah,
so
and it's actually quite purposeful once we get into this. So I often, when I do PD with kindergarten teachers, put up pictures of number charts from 1 to 10 and they have all these beautiful different sized, and the 1 object's really huge and colourful and the 10 are really small. That's all great, but they're with the later counting principles. What students who have maths difficulty need to see is that each number increases by 1 and the size between each number, or the increase, is the same. So the amount of increase between 2 and 3 is the same as between 4 and 5. So that's why this becomes important.
And that's what you and I have discussed, redesigning some posters, particularly for children who struggle.
Yeah, that's right.
And you can understand that people put a poster thinking it's visual, but it actually might be causing some issues.
And it's knowing what to do when and for whom. Yeah. So that's why we go back to that picture of my little Josh. You know, you've got to look and listen and know what you're working with.
But an example of that would be, that poster would work for any child in the, if we have one, so we might as well have one that works for those kids.
Yeah, okay. Lovely. Okay, so if we can go on to the concrete, we'll go down to the visualizer. Now, at home, if you could grab this sheet, and you'll need 5 counters. I do realise you're in lockdown and it's all very tricky, but the reason I made these the 18mm is that they're see-through this size, whereas the slightly bigger ones aren't, and we're going to move to the numbers at some stage.
And you can see through it. That's sort of magnified a bit.
Yeah, it does. Yeah. Okay, so you'll need your 5 counters. I'll just get mine. Okay, and I've got a dice here. I'll just move this out of the way, and on it we have those subitized fingers from 0 to 5.
Yep. Okay. So we're now sort of turning into a bit of a game.
That's right. Yeah, fluency practice. But
and a bit of disposition.
Yeah, that's right. And whenever we do the games with learning support, we only change one variable in each game. So we're going to do the same game over and over and just change one thing. Okay,
so by changing the one variable, if we just head there for a moment, it allows us to spot something. They were okay here, but we change the one variable and then they can't do it. That helps with our formative assessment.
Yeah, it does.
And so we can, so otherwise the gap's going to get, if we can close it quicker, that makes a big difference.
Yeah, and it also reduces the working memory load of the actual procedure of the activity, so we can focus on the maths.
Because some children have trouble with what I'm going to call game fluency. They don't understand about dice, so you've got to do all of that. Yep, okay, so let's have a go.
All right, so let's do it at home. I'm going to roll my dice, and I'll do it first so you know what to do, and then it's your turn. So if this was me, I'd roll my dice, I make it, and I say 2, and after I've matched my word and my finger, I then put 2 counters on, working from left to right.
Okay, so we're building that. Right? Yep, okay.
So now you do it at home. Let's do it, and I'll do it with you together. So the first one I want you to do is 1. So we say 1. Good.
And I put the 1 counter on.
Brilliant.
Okay.
Now don't clear your frame. The reason is we want this idea of when numbers live in relation to each other and which ones are worth more and which ones are worth less.
This is part of that numerosity idea.
Exactly. Okay. So we spin again.
3.
Now.
Okay, I've got to do the 3.
Good timing.
So 3, and then I'm going to put 3 on here. So
that's
1,
right.
2.
Now.
Okay, so now.
Oh, hold on. That doesn't look like 3 to me.
No, that's what it is.
So we want to match, which is where that desk visual came in, because I actually had the picture of 3 of them. Now, a child that goes to count, you just pop your hand on, or we can see without counting. And go again. Okay, we'll just do one more for time. 5.
Okay.
And you.
So I'm going to do the 5.
Good.
Down here, I made a mistake last time, so I'm...
Leave the 2.
Yeah, okay, so now I'm going to go...
Yeah.
And that takes me to 5.
It does. And
did you want me to count on or
no,
not?
I don't want you to count at all. I want you to see.
Yes.
And we want to explicitly say, there's 5 boxes. It's called a 5 frame. We have 5... Oh, I'm struggling with my cameras here, sorry. We have 5 fingers. There's 1 finger for each box.
Okay,
You've got
wow.
all your fingers up. You've got all your boxes filled. Because then ultimately we want to get to this idea of 4.
Ooh.
Oh, there's 1 less. And you can see there's 1 less. So it's 1 less.
Oh, okay. So there's one other thing I'm just getting from this, just before we go on. When we talk about this concrete representational abstract, earlier we said there was the missing link. Now I've noticed you've been very explicit in the language that you do, and even the timing of the language.
The timing.
So can you just take us back to that just briefly and explain what you did, just so that everyone's really clear? Yeah.
Yeah. So that we were on 5, and we went to 4, which is 1 less.
Less. Yeah.
That's right. So we want 1 less. There's my 1, and the action of less matches.
Now, when you work with the children who have, do they start looking at the numbers underneath and making any relationship?
That would be lovely. But guess what we're going to do now?
Yeah, that's right.
Okay. So if we think back to that triangle, we had the physical material with the oral language, and we had the written numeral. So now we're going to, with the concrete, bring in that written numeral. So we're going to do exactly the same thing, but on this, and we call this not a number line. We call it a number track.
Because we're now talking about the spaces in there, not the length particularly.
So we'll do this again, and you can do it at home with me. So we get 2. Now, before you do this, I want to see your hands in the word.
2.
Good.
Right. And I'm going to put it here, so we've got our 2.
Excellent. And they're just being exposed to that numeral 2 and the match there. So then we'll do
5. That's a bit. Okay. So I'm going to do the 5.
5, and if we go to count, which is remember all fingers.
Yeah. So I've got all.
So
obviously, okay.
All
so
counters.
1.
Great.
Yeah. Okay. So and I've got to 5. I can see.
Yes. And if we're not sure, point to the desk visual in front of them just to reaffirm. So we're wanting them to trust this subitized amount and this visual more than
and not counting.
Just because counting is a separate skill. We're actually trying to get this focus of quantity. Okay, and should we just do one more and then we'll stop? Okay, so say we get 3.
Okay, so I've got to do the 3. And
nice matching of your quantity and your word.
Okay, so and I've got this here, so I can start to. Now, what happens if I pull 1 and 1, or can I pull 2?
I would pull 2.
Yeah, that's what I was thinking. Yep.
And for students that struggle, look, they make. I really struggle with the camera. Sorry, they make 3, and I would actually even just get them to.
Okay, touch it. So there's a physical.
If they're really struggling, there's 3, and then you move the others way for them. So that's at the concrete end. And I want at home you to really think in your head, the thing I had all the time was that connection. I'm going from the material to the oral language to the symbol. After this, the last activity that we'll do,
that's subtle. Yeah, okay, yeah, I can. So there's where you've changed.
Okay, so we're going to do exactly the same thing. We're not going to use this number line because then they just match. We're going to go back and use this one. So we're still with this concrete. We call these discrete objects because they can be counted with one-to-one correspondence or picked up or touched and matched. Okay, so same thing.
4.
Fingers
do I need to do
first.
the 4? I want to link to that.
At the same time.
4.
Good.
And then put the counters on. Now, would you rather me move 4?
I would just rather you move 4, that's right.
Okay,
and if they're having trouble,
deliberate mistake at home just to make that point.
Remember, look, 4, there's 1 less.
Okay.
Oh, you've got 1 less.
Because when I was moving them one at a time, I'm pretty close to counting. Yep,
Whereas you're better off to, because can you see we've got the 4 there and we've got the 4. So we're trying to get all those pathways together. Okay, and then we'll just do one last one and say we roll I'm going to fudge it here, a 1.
Okay, so a 1. So I do 1.
Good.
Okay, now I can see.
Now you see just one finger, that's right.
So that's the one finger I can remove.
Now you're operating fluently.
Oh, yes.
Okay, so that is a concrete progression.
Yep.
We often expect students to get from here to here.
Yeah.
And it's a hard jump. Now, I would have had you do this at home, except for you poor people are in lockdown. So we're going to use just a slightly different material. We're going to do exactly the same activity, but I'm going to use these beautiful cubes. Yep. Now, this is why I actually made these 2 centimetres as well, because these are also 2 centimetre
they match,
cubes.
Yep.
Now, usually I said we're using them as discrete objects. I've made these, and the students will make them themselves as a 1, a 2, a 3, a 4, and a 5. I don't mind which way you do them, but they're all ready and the students can click them together. So we're not counting each time, we're actually having to pick up the correct one. Now, to start with, I would keep these in order.
Yeah.
Once the students develop fluency, we have them in a random order so that they can see, 5 and 4, they're pretty close, yes?
Okay.
How are you going to know which one's 5? Because 5 is longer and bigger. So that's okay. So Paul will do the same thing. I'm going to go back to my finger dice.
Yeah.
And we're now at that representational level. So I will
what's changed? Because we've just moved from this number track.
Yes, we're down.
Now what's happened here? There's a subtle change.
There's something that's been introduced. Spot the difference. And it's the 0.
Yep.
Okay. Now the reason we need the 0 is because 0 means we don't have a counter or a block.
Yeah.
1 is actually at the end.
Okay, so now we've got this length idea starting to be, as opposed to being in the space like on a track. Yeah. Okay, so when you have tracks, they often have something like start.
Which is 0.
Yeah.
Yeah. And that's where we get the students who make the mistake of moving to, and is that the one that I'm on or not?
Yeah.
So it's really important that we actually explicitly explain 0 is no block.
Yeah.
1 is at the end of one whole block.
Yeah, not travel that long.
And you'll notice when students are older with fractions, that's where we get confused as well. Because there are numbers in between here. Again, magnitude, numerosity, comparison. Yeah. Okay, so can you make, so I've rolled 2.
So make the 2, yeah.
Now, can you
I'm going to go directly to
I'm going to say you're a little bit advanced.
That's right.
And we don't need them in counting order.
I'm going to there.
Look at that too. Now, I'm going to be a bit sneaky as the teacher, and this is also a representational manipulative. It's called a bond block. And I'm going to check that it is too. Okay?
And I can see here, where the progression starts to happen, because I can still sort of count 2.
Yeah.
But I can't get away with that when you
can't get away with it with this one, because the difference is
no
there's no notch, and that's a really important jump. Okay, so we're doing 2. Okay.
I'm just aware time is...
I'm talking too long.
No, I'm asking too many questions.
Okay, all right, we'll just do one more and then we'll go. So then if we go up to 4,
okay,
now you're going to have to do your fingers.
4, do the fingers now.
And say
4.
4, good.
Now, do I swap that?
No, pick up the correct one.
Okay, which is there. Boy, you're a bit tough there. Well, I'll tell you what, I was in trouble. All right, so there we go.
And then I am going to
check it.
It's the 4.
And it's about length and all of that sort of stuff.
And then when we move on to the final level, which I'll go a little bit more quickly, you can see here we've taken the numbers out. Yeah. Okay, now technically we can see 3 without counting, and we know 4 is the one before 5.
Yeah, so that's the numerosity.
That's right. So we do the same thing, but instead of using these individual blocks,
one-to-one stuff.
That's right. We can then go to this one. Yeah. Now, when you look at assessments of students with dyscalculia, they find this idea of a mental or an empty number line very difficult. So we are wanting them, when they see this 4 or this 4, to know that it's about here.
Okay, so basically getting that judgment, that
That's
estimation,
right.
and that's why length is important.
That's right,
Yeah.
and then we can check it. So we're going to start, if we can just go back to the PowerPoint
that's right,
and
yep.
just go on to the next slide after that. We're
Yeah.
going to stop there with the counting.
Yep.
But just in summary, you can see that we've gone through this concrete, representational, abstract all the time, linking those three.
Okay, so let's go to the next one.
Yes.
Yeah, so there's that link. Yeah.
That's right. And so not only did we do it for one number, we were introducing the idea of that relationship between numbers. So whereas 3 in relation to 4, whereas 7 in relation to 8.
Okay, so that's why we got the 7 and the 8
That's
and the
right.
length and the things there. And I noticed you use 10 strips here.
Yes, I'll get to that in a minute.
Yeah, okay. So, all right.
Okay, so the next thing we would do is repeat this activity, but we want to be explicit about that comparison. So we might use the word one more if we're using counters. We then do the activities again, but we use the word one greater.
So this is where you make the subtle single change. Yeah.
And then we do it again, but we use the word one after. So we all know the early years assessments.
Yeah.
What is the number after and what is the number? Now, whenever we do things in one direction, we always then have to do them in the other.
Yeah.
And you ask when children learn language, yes or no, which word do they learn first? They all can say no. A long time before they can say yes. Okay.
Yeah.
The one they have to practice is saying, yes, mummy. Okay.
Good tip.
With this, we go forwards quite easily. Going backwards is harder.
Yeah.
It requires more practice.
And you got to hold in your head and do. Yeah.
And I often think we give students less practice because we assume they've got the forwards, but it is actually harder.
Okay, good point.
Now, after we do this on the next slide to 5, so there's our beautiful progression to 5.
there, and then you
Guess what we're going to do it to?
repeat the same idea.
About up to on the next slide.
And that's the nice
up
bit
to
about
10.
sequences.
Yeah, and so you think, oh my goodness, we're putting in all this work to 5. But when you repeat this and you want to know that 6 is 5 and the next number after, you don't know that 1 or 8 and 3, and you don't know that 3, we're in big trouble.
And look, this part to anchor the sort of
That's
thinking.
right. So you can see on that slide, we go from the linear 10 strip and then we cut it.
Then to the tens frame.
Yeah, so that's that same progression.
Okay.
Now, that is the counting section.
We better get to
Done.
the calculation.
Yeah,
one here.
okay.
That's it here.
All right, so the next thing when we look at the Dyscalculia screener is students who have maths learning difficulty don't know as many facts. Okay, they're also not only about the facts, they don't have the understandings that go with that. So if we go to the next slide.
So we're going to do it. So we're going to do 5. Now this is you often use the maths assessment interview, or
Yeah,
it
I
actually
love
comes from
that
Victoria.
Victorian one. Yeah.
And you've noticed when you've done this testing with the children, this question is quite an indicative question. So
That's it. And there are a lot, that assessment is fantastic, but it's long and you need to do it one at a time. There's a few key questions that if we just ask one, we can see.
Yep.
So if we go down to here, for this 5 at 8, when we're looking at students with maths learning difficulty, there's a clear progression. You have the 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, up to 13.
I remember, do you remember the girl when we had the clinic, year 7 she was, and the question was something like 28 and 37, and she did 28 strokes and 37, and then counted everyone. Yeah, that's an example.
Okay, so that is our highest level. Okay, next we start at 5 and we do 1, 2, 3, 4, 5, 6, 7, 8, and we go 5, 6, 7, and we do a lot more counting, and then we understand the commutative property, which requires knowing which is larger, that 8, which is why the whole thing of that quantity with that numerosity idea is so important. 1, 2, 3, 4, 5, and they've got 8, and this is all counting. Students who do this after year 1, and in year 1, I would only give them questions where they can count 3, because after that we need to be using strategies, is at risk of having learning difficulties and requiring intervention. So we go on to the next slide. The reason I say that is that when we look at our curriculum, back in year 1, they're having to partition. So they have to see that 8. We go down up there's fine. So if you make the 5 for the 5 question, and I'll make the 8, can you see the 10 and the 3?
Oh, yeah.
Okay?
Yeah.
All right. So if we can partition, we can actually do that question without counting. And that's way back in year 1, that's splitting of quantities and part, whole.
Yeah, and a lot of the games you play there is really about the splitting, like that shake and spill.
That's right. Example. And back in our kindy and pre-primary curriculums, we're doing part, whole. Okay. Then from there, if we look at that PowerPoint, after that we're looking at the strategies in year 2 and developing there, just some of them there. Yeah. And then by year 3, we're wanting that recall. So if you've got students that are counting by ones in year 2 and especially year 3, they are students who really are missing a lot. And if I can just go
So how do we sort of...
What do we do?
Yeah.
Okay.
How do we, right. Last week we were trying to avoid happening, but it does happen.
It does happen. And
so we need to...
that's right. So the first thing is they don't understand, they don't know those bonds. Bond is a UK or Singapore term for the parts that join together. Yeah,
it's like the basic facts.
We call them number facts, that's right. So I'll just get my 5 and my 8.
Okay.
Sorry, block. All right, so they don't understand that 5 add 3 is 8. Yep. They also don't understand the commutative property of addition. Yep. That by changing the order of the parts, the whole size stays the same.
So in our curriculum, we call it rearranging the parts, which is the commutative property.
That's right. They also don't have the understanding of subtraction. So addition is part, add part equals whole, and subtraction is whole, subtract part equals part, or whole subtract part equals part. So they don't have those understandings, and then we need to use these to develop strategies. Okay. So what you're saying is the children who are having the difficulty always sticking with the counting in one, which is very labour intensive. And so it's to build. So how are we going to build these strategies? Because they do get wedded to the. They do. That's right. So if you can just go to the next slide. We've got a little picture of a desk visual. Okay. Yep. Now, students who have maths learning difficulties, if they have working number difficulties, they need to be able to have something they trust more than the counting. So we need to get these bonds of 10. Now, most of them will remember 0 and 10 and 1 and 9 and 5 and 5 once they've had the understanding. But these last ones, the 2 and the 8, the 3 and the 7 and the 4 and the 6 are really tricky.
Are the tricky ones. So I see this as to go on the potential on the back of your board. Look, I've been working with some year 9s that can't add to 10. They don't want to sort of be... You've got to think about their dignity.
Yes, you don't want some great big bright things plastered on the top of their desk, so every single person who walks around knows, hey, you don't know that. Yeah. Okay, so this is discreet, but it's something that they can use all the time and go on their desk. So let's look at a very quick progression of how we could do this.
Okay. Do you want me to move on to the next slide?
Oh, no, just down here.
Sorry.
That's all right. Okay. Go so now, what have I got? 7 minutes left? Is that right?
No, we got time.
Okay. All right, so we're looking at this question of 5 at 8, and I'm going to go through that concrete, representational, abstract. Okay, so we've got the 5 and the 8. I've used the commutative property. So at the concrete level...
Well, hang on. So you've now turned that round to 8.
I have, that's right.
Okay, yep. So and we often talk about the bigger, larger number, but that's the numerosity thing coming in.
All right. Yep. Now my 5, I want to check it's 5 without counting. So I've made the standard arrangement. Okay. And then I want to look at this and partition it to add it on.
So you've literally bridged the 10.
I have, but it's very different going 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13.
Yeah, that's labour intensive.
It is.
Potential for mistakes.
Whereas starting with a 5, having to look at this and do those partitions is much different.
Okay, there's 2 messages coming out here. It's fairly clear. Having these images or pictures, the subitizing image, being able to split in that, the length idea and the tens frame, the same tool. Yeah. There's a lot of consistency that's happening here. Okay.
Okay, so we go from concrete. Yeah. And next comes representational. Yeah. So we're wanting to do our 8 and our 5.
Okay. So how has this, it feels concrete to me in that you've just lifted the something we often call concrete materials. Yes. So how's this representation?
Yeah, so I would say that's a manipulative bit. Yeah. Something you can pick up, you can actually manipulate. Yeah. Whereas this is a manipulative, I can pick it up and manipulate it. But the reason it's representational is it represents the length, but you cannot discretely count by ones.
And pull it apart.
That's
and do
right.
That. Yeah, okay.
But it does mean that I can still break up exactly the same as we did with the tens frame.
So there's the partition.
That's right. And then I need to know those bonds to know that the part at part equals whole.
Yes.
And I have split this from a 2-part bond to a 3-part bond.
Okay.
And then I need to know that that is equal to 13.
Now, there's a lot of prerequisites going on there because you've used the commutative property.
That's right.
You've used the facts that add to 10 because you've got 8 and 2 is 10.
Yes.
You've bridged that 10. But yeah, I can see that it's almost self-correcting. The length is the same.
They are, yeah. So if they had to put a 1 and a 4, that also would have worked, but it wouldn't have bridged 10.
Yes, yeah.
Okay, so there's a whole lot of stuff in there.
Okay, yeah.
Just another representation after that is you go even more abstract, and you might start with the 8, and then you might add your 2 to get to 10, and then you could add your 3 to get to 13. But that's quite a jump.
And that's your empty number line sort of idea.
Right, yeah.
And essentially what the children are doing is, because they don't have the capacity here, you're dumping your thinking onto the
page.
And this is a way of doing
That's right. Okay. And then the final one is your abstract.
Yep.
And that is either being able to go 8, 10, 13, or just ideally recall year 3 straight to 13.
Okay. Yeah. All right. So we want to do something on word question.
Problems?
We've got a little bit of time,
yep.
so we'll take us into that sort of thing.
So we've done some addition. And then if we look at word problems, we're going to use a very similar approach, that concrete, representational, abstract, but making sure we're specific about that language. So if we look at this type of word problem, Jane's got 25 pens. She gave 15 away. How many does she have? Students with maths learning difficulties can probably do this, okay? Especially if they have the assistance to actually do the calculation with materials or something. The reason they can do this is the numbers match the order of the word question.
Yes, okay.
They have gave away, that means subtraction.
Yeah.
However, that is not a realistic representation of a word question and the breadth of them.
Okay, so there's a couple of things going on here. Sometimes the early word questions that children get build to feed their misconception.
Yeah.
So you've got there, they calculate in the order that the narrative. Okay,
yes,
that's one
right.
there. Okay, and you're right. And then they get, this works, and they think it works all the time. A bit like keyword strategies. Yeah, backfires about 50% of the time.
It does. So if we teach students to highlight the keywords and then match keywords to operations, we're actually, I'm going to be pretty brutal here, but teaching them to fail about half of the time.
Yeah, it's about a 50%,
Because words like bought and spent, I can equally use in addition questions as I can in subtraction questions.
And the more is a classic example.
So let's look at one of those examples.
The other thing I just noticed here, and this is subtle, I don't want to get heavily into it. She have. The tenses often change.
They do.
No one is good. But there's a YouTube video clip that people can watch that's from the
Yes, I nicked this question from your Victorian.
Okay, so if I want to read more, they can see more about it. So let's have a look at this one.
And so this one, we've got a similar story so it's still subtraction. After giving away, apparently, some cards, Jane now has 17 cards left of her original 30.
Cool.
How many did
I
she
can
get?
see why
All right. So now if you use those previous immature strategies of following the order of the question and using things like take away or subtract, even if you try addition, none of those are going to give you the answer.
Okay.
So what do we do about it?
So this is almost when we going back to last week, trying to prevent rather than cure. So if we can know that this is a possibility, we need to be aware of the types of questions that are coming.
That's right. And so I realise we've only got 2 minutes left, so we'll have a look.
Once again, can watch a video here if you wanted to. Yeah.
Okay, so what is a better approach?
I'll just take us off so everyone can see. Yeah.
So what a better approach is what they call a bar model or a strip model or a diagram or Singapore maths. It doesn't matter what you call it. It's about using this part-whole diagram. So if we understand part-whole, when we read that question, we need to develop a concept or an understanding of what's going on in the question, rather than just looking at matching words. So when we read that, we can say her original or her whole was 30 cards. So I think if you click the...
Yeah, that's right, we go. Yeah, we might be able
There we go. can draw it, but I'm just conscious of time. That's all right. Okay. So the whole was 30. Yep. She gave away some of them, and she gave away. I can go to the next slide as well. Sorry, go on. No, that's all right. Okay, so out of the 7, she's now got 17 cards left. So she gave away a certain number of cards, and the grey area, she's got 17 left. So there's 2 parts there. There's the part we gave away, we don't know. That's that should have a question mark.
Yep.
We've got the cards left, which are 17, and we know the whole. So if we know the whole and we know one part, we're missing a part.
Okay. What do we need to do to find the part?
Yeah, and there's a few things you can do. You can use subtraction, which we've got there. You can start with the whole of 30 and subtract a part. Or you can actually go, you know what, I've got a part of 17. I can add on the unknown part to get to the whole of 30.
Well, so there's a lot going on here. So so I can see now why you moved from the blocks. So we had here, so we had some blocks that you could count. To a length, which was the blocks that you had, because they actually built in my mind this part whole thinking. And now those words are not just linking to addition, they're linking to the idea that addition and subtraction are related.
That's right. And
no wonder there's some issues going on.
And our biggest, it was beyond the scope of the time of this, but when you look at subtraction, your major indicator is students with maths learning difficulty only solve subtraction by counting back. And often by ones, whereas you can add on. So it's that, and if I can just say one last thing about the problem solving, you would go through that with counters on tens frames. You would then do it with a representational manipulative like the bond blocks or an empty number line. You could then do it abstractly. It's not just end up at the abstract.
We don't just suddenly end up here.
Because of time,
you've progressed in that one.
That's
now,
right.
There's one other thing that makes sense to me here. Clearly, you can start to see links to algebra. I can just see like that question mark could be an X.
An X, that's right.
But so we're really setting them up for later as well. But look, we're time that's sort of just goes so quickly.
It does.
So we've got a little summary slide that we just like to review. So we'll just show you that, and then and so we have some time for questions. So you want to run through where we've been today?
Yeah, that's right. So I wanted people who thank you for giving up your time after spending days on screen. Well, on a screen where they are in Victoria. Not fun. I hear lockdowns going another 3 weeks. So we wanted you to look at what was a learning difficulty, and it's this idea of not connecting the quantity or the amount with the number, and why this is important. And so we went through a progression using concrete, representation or abstract, linking the quantity with the word and the symbol. We need to do that in counting. We need to do it in addition. We need to do it in word problems.
Okay, so, and look, we could have modelled that, unfortunately, our time in subtraction and so forth, but it's very much the similar approach. Look, I can see how precise it is, how lockstep, but after a while, that would just come. You've obviously been doing this for many years. It just comes naturally.
Yeah, and you'll notice we only used a few materials. Okay, so I would rather use the same 10 frame and the same cubes and the same blocks, so rather than pulling out a different material every time. Yeah,
because these kids have got to understand the different tools. Right. Look, thanks very much for putting up with us today. Yeah. And look, if there's questions, we actually pre-recorded this, but we'll be here tomorrow.
I'll be back.
Yeah, maybe the clothes might change. So thank you very much for that.
Lovely. Thanks for your time.